The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to GTMA's latest webinar, our first one for the summer of 2013, Mobile LiDAR Directions for Transportation Agencies. My name is Rob Dinges. I am the President and CEO of the Geospatial Transportation Mapping Association. We will begin today. We're very fortunate to have our speakers today. Paul DiGiacobbe is Director of Strategic Technology and Incubation for HNTB Corporation. I think for many of us, when we hear innovation or cutting edge or the application of new technologies, we often look to HNTB to see how they're being applied, and we often see them first applied in the HNTB family of companies and associates. And so we're going to talk about a couple of projects that he has worked with as it relates to this issue. We also have Brett Wood with Florida DOT. He's the aerial mapping manager for Florida DOT, and he will be talking from a state perspective as it relates to these technologies. Let's go to the next slide. The two projects we're going to be talking about are with I-95. Kind of the overall agenda here is that we're going to discuss the system capabilities, get into the projects, the I-95 and the I-80 project. Then we'll have Brett talk about the agency issues. Then we'll do Q&A, and then we'll be done. This is being recorded, and so we will be sending this out so that folks will be able to listen to this recording later if they were not able to join us at this time. And with that, we'll go ahead and turn this over to Paul. Paul?
Thank you, Rob, and welcome everyone. Yeah, I thought it would be important to begin the webinar with a little bit of a qualification on the mobile LiDAR systems and how we at HNTB apply them to different types of projects. So I think it's really important to understand that there's a key distinction between the different types of systems in their ability or inability to capture what we call survey-grade data. All of these mobile mapping systems have three primary components. Obviously, there's a LiDAR sensor or sensors, some type of GPS positioning, and then an inertial measurement unit. And how those systems, those integration of those components are done really can dictate the level of accuracy that you can achieve with these the variety of mobile mappers that are out there. We know that almost all of them can do asset management type collects with very little extra work or any specific types of equipment. But then once you get into the survey grade application, where we're using it as a basis of survey for our design methods, then you have to be a little more careful. And that's really where we start talking about using supplemental control and things of that nature. I would be remiss if I didn't mention the integration of cameras. They have been absolutely indisposable in many cases when we are extracting data out of the LiDAR, where the points don't tell you too much information, but when you can have a camera image with that point data, you can very clearly see what you're looking at and identify break lines and things of that nature. So as we discuss the this survey control and acquiring the data and using it for a survey grade result, and I speak to survey grade in our terms, we're talking about a ½ inch, a plus or minus, the absolute accuracy. So when we say absolute accuracy, we're talking about where we are on the ground. So the relative accuracy would be how well the laser sensor measures within itself, right? So you're not really worried about where you are, but you can measure from ground to a clearance point above or distance across a roadway, things like that. Those types of accuracies can be quite higher or quite sharper than what we're talking about here. But where we physically are is what we like to refer to as the absolute accuracy. So in order to achieve that survey grade accuracy, we typically like to have a series of control points out there, typically placed at about 1,000-foot intervals along your project corridor. Those are obviously surveyed in, and the points that we are using for the control survey versus quality checking, the ones to control the survey points, you must run some type of level loop through them to bring down the vertical accuracy to where you want it. And then, of course, the multiple passes, all the different raw LiDAR data sets are adjusted to that final control network. One other thing that we found to be very effective when you're trying to achieve this half-inch accuracy, range filtering, and what we mean by that is just cutting off the data from a given pass at a prescribed distance from the sensor. Because as you can imagine, the further you get from the sensor position, the looser the data will get. So if you cut off or range filter the data, you can bring this collect into spec with that type of procedure. Okay. So with that said, let's talk about a few projects that we've been involved with at HNTB. I-95 Express Lanes is a 30-mile long project under construction currently. It is a design build. The purpose of it is to convert the current HOV lanes to HOT, so from high occupancy to high occupancy toll. In order to do this project, we actually acquired both airborne and mobile LiDAR, and then the data was fused together into a single data set. And what was really nice about this project was, for a lot of our designers, and this was about 2 years ago when we started design, the purpose of the LiDAR collect was to do it for the terrain modeling for the roadway work, the design work. But what we found was not only were we able to do our 3D design off this basis that came from LiDAR, but we were also able to help our ITS team that did the intelligent transportation system and changeable signs, for line of sight, all kinds of things that really we didn't think would be available to them. This became kind of that single source of truth that everyone was applying their design efforts to. We also found sound barriers that they thought they'd have to do a secondary survey for. The structural portions of the project were benefited by the data. And ultimately, we can use the LiDAR data in a project visualization sense. So in design build, a lot of the time, we're trying to find a better way to create a portion of the project by making it smaller or reducing the amount of right-of-way take. So all those things are kind of worked on the fly in the design build realm. And what this next video show you is really what we were able to do. It'll show you a little more of the background of the project, but then there's a video at the end that shows you how we integrated the LiDAR data with the proposed 3D work. So this is your location south and west of Washington, D.C. through Arlington. That's a pretty good video of the size of the facility, very large, very difficult to survey from the conventional means. Now you're looking at the terrain model that was extracted from the LiDAR data. So all of the elevation information that we use for design. This is the imagery that was available to us from the mobile collect. And of course, this is the 3D model that is integrated with the LiDAR. So LiDAR being blue and yellow, and the proposed work there is in white and yellow. So, so again, very effective way for us to communicate with the client and our partners about what this potential change might look like. The I-80 project that we worked on was a conventional design bid build project, but it had some challenges with funding, and the cost of the survey was really holding up the overall project progress. So our team came along and recommended that we use a mobile LiDAR system for this widening, which is inside to the median, going from 4 to 6 lanes. We were able to do that with mobile LiDAR, and we actually offset the cost estimate by 50%. So it was about $500,000 savings, somewhere in that range, and we were able to accelerate the schedule at the same time. I can tell you, some of the things that we learned that were very important when you're dealing with a grass median. We had to make sure that we timed the LiDAR collect right after when the grass was cut. As you can imagine, a line of sight instrument like that that's on the back of a van, the lower that grass is, the better the opportunity to actually get down to bare earth. So that helped us tremendously in coordinating that with the DOT's maintenance crews to make sure it happened. But in the end, what we were really trying to deliver was conventional types of information that you're looking at here. This is the extraction of the LiDAR data into brake lines and spot elevations by using the TopoDot tool from Certainty 3D. And our team was actually very new to that procedure, microstation users, but very new to TopoDot, but picked it up very quickly and produced very, very reliable results. In the end, we got a very nice survey-based map. We were able to use the information from the roadway design in this particular case using GeoPack. Was helpful for structural design. A lot of the bridges had to be altered, and they were able to really do a lot of things with the clearance checking and just having a lot of information to work from. I don't have a real fancy video for this particular project, but what I do have is a series of screenshots. So this is an interchange where you're looking at the actual mobile LiDAR data that was collected in that area. This is the integration of those extracted brake lines and spot elevations with the LiDAR data. This next image is just those brake lines by themselves, brakes and spots, and then finally the DTM that resulted from that work. So really that's kind of the progression. Once you've got the LiDAR data in hand, there's a process to go through to extract what's needed for the particular design and then turn that into something that's usable in the design tools that we all know and love and rely on every day for production purposes. So they're the two projects I wanted to show you, and at this point I'll ask Robert to turn the controls over to Mr. Wood, and Brett will show us what he's got from the DOT side.
Good afternoon, everyone. My name is Brett Wood. I'm with the Florida Department of Transportation. And let me see if I can pick this up from where we had it before. Can take it that you can, Paul, and then you can see my screen. Okay.
Yes, we can. Yep.
Okay. Let me know if you can't hear me. I know we got some thunderstorms out back, so I'll go ahead and get started. Most of the conversations I've had with DOT personnel, the challenges are fairly similar to all most of the state transportation agencies. Where we really differ, I think, in some cases, is how we address the challenges, and a lot of it I find is based upon the existing structure of the organization. So I thought the best thing to do before I get into explaining how we approached it here in Florida, I thought it would be good to kind of give you a quick background about some of our structure. We have 7 districts and a Turnpike Enterprise, and then of course the central office. The state surveyor, John Krause, and myself, aerial mapping manager, and most of the supporting survey and mapping personnel are located in Tallahassee at the central office. Most contracting and project management for our work program projects are done at the district level by the district project managers, surveyors, and engineers. Mainly what the role is of the surveying and mapping central office is to provide procedures, technical support, help establish guidelines and policies to support the transportation department as a whole. So we do, I would say probably 90 to 95% of all aerial mapping, as an example, is done for the Department of Transportation, is done by consultant. We have an aircraft and do some aerial mapping with a DMC camera from Intergraph, which is now Leica, but it's mostly on a support and emergency asset, damage assessment, asset management kind of component, and some county mapping. So most of our transportation photogrammetry is done by consultants, and our mission was to maintain that with the implementation of utilizing new technologies such as mobile LiDAR. It's very challenging, but we felt in today's markets and with the budgets the way they are, that we probably, as a transportation organization, wasn't going to get into the mobile LiDAR mapping acquisition ourselves. We most likely contract that out. So that's a little bit about our organization as far as structure is. The department goal, our new secretary, Anant Prasad, well, he's been there for quite several years now, but one of the main things he brought in to the organization that I think is taking hold and also has been championed by much of the management is to be consistent, predictable, and repeatable. And that's been sort of a challenge for us as an organization because, as you saw from the previous slide, and also you can see some here where the districts are, one of the great things about having districts is you get local input and local control over what happens in those areas for the public. But the downside is, how do you maintain consistency and predictability as an organization if your project management and your contracting is done from several different districts? And that's sort of the challenge, part of the challenge of the Surveying and Mapping Office and the State Surveyor, is to bring some consistency, at least as far as policies and procedures are concerned. Some of the main components we had to, that I think challenges that everyone is going to have in an organization, is research and testing. You know, we have an obligation to see that we protect the public funds, so we're hesitant to just try anything that sounds good without a little bit of background and a little bit of testing and some, more than just some marketing brochure. Also, too, once we start using it, then quickly, if it is the technology we think it is, in the sense that it's going to save the department considerable money regardless of the technology, we quickly have to establish guidelines for doing the work. And one of the reasons why, and that's kind of a key component there, we've developed guidelines for mobile LiDAR mapping, and we chose guidelines specifically because the technology is changing so fast, and the fact that we're in some cases new to the technology, we didn't want to burden with a full-blown procedure. That most of you probably know in your processes, procedures are addressed at certain periods of time. We have a strict review practice, and then of course they get published, and it's a long, involved process to just change procedures. And therefore, we felt it would be better to come up with some guidelines that we could support, and at least get consultants and department staff working together on the same sheet of music. Then we had to develop, I don't know how familiar some of you may be with standardization of scope, but the Florida Department of Transportation has worked a long time with standard staff hour forms, in the sense that we have a set contracting mechanism where it's a very involved spreadsheet for each of the components of a particular project. Of course, there's surveying and right-of-way, there's location surveying, right-of-way mapping, they come underneath the design criteria, and also there's aerial photogrammetry, and now we're introducing in Florida, mobile LiDAR guidelines. And so we needed a workflow that could reflect some of those different tasks that could be used to help project managers not only estimate but also track progress on projects. And in a lot of cases, they have experience, but they aren't going to have the same level of experience as say, someone who's working with the technology every day. So the guidelines and the staff hours and the general scope had to be something that both could apply to technical issues and be understood by the layman as well. And the thing to get from this particular slide, I think, is most important is how they are tied together. We can't really change one without changing the others, and in a sense, so it becomes an iterative process, and that's something you'll hear throughout the remaining slides, is that the process is ongoing. Looking at research and testing, one of the reasons that I think our organization fit well in the research and testing of mobile LiDAR is the fact that, of course, in the airborne photogrammetry section, we've been applying inertial measurement units, sensors such as the digital camera, and GPS corrections for many years. The only difference being we actually tie everything to a sensor event that's a camera, and now it's being an active sensor, being a LiDAR sensor. And there's been airborne LiDAR for many years, but it's mostly been on the large scale. I think for the discussion here that Paul was talking about, there are beginning to see some low altitude mobile LiDAR applications that are approaching some of the accuracies that he discussed. So for the most part, if the term low altitude LiDAR is discussed here, it's mainly from the same standpoint and the same survey grade accuracy that Paul was speaking about. What we did first when this new technology, of course you have leaders or individuals in every organization that take an interest in new technology, but one of the benefits of having flown and acquired imagery, we had professionals in-house that were able to quickly digest and make use of the new technology from a close understanding with similar technologies that we had been using. So that was really a benefit. And one of the challenges, and I think I covered at the very end, one of the key challenges is how we maintain that expertise going forward. That's going to be a tricky concept because more and more technologies are coming on board every day. But the key is the organization, any organization that's going to utilize this technology effectively has to have a level of expertise in-house to make that happen. There's just no shortcut to that part of it. One of the things that we did early on was establish a mobile LiDAR task team. The state surveyor, John Kraus, called together district surveyors, and we got representatives from each of the districts, persons that were involved or were very interested, were going to be champions for the district, were involved in forming a LiDAR task team, mobile LiDAR task team. And the directive of the mobile LiDAR task team, the first directive, was to come up with some consistent guidelines that we could utilize in establishing a workflow and sort of moving along forward and actually using this new technology effectively. We had done a few test projects. We had tried a few things in different districts, but we really needed to put our notes down on and come up with one sheet of music and say, okay, there's going to be tweaks that have to happen. There's going to be changes that have to happen, but we need to put something in writing to get everybody moving in the same direction. And so hence we also incorporated the input from several consulting firms that also were familiar with this technology and whom could contribute, and we definitely needed that real-world experience aspect from the consultants, and they provided us with a lot of valuable information. And together the team came up with our first set of guidelines, which came out last year. Before I jump to that, I would make mention of what I have here on the screen. One of the things that we needed to do with the districts was identify some projects that weren't already, high risk or very difficult projects. We wanted to choose a few projects that didn't have, a lot of potential problems that could go wrong. We wanted to pick some fairly straightforward ones that we could use to compare to the technology to traditional methods and other things. So we looked for projects that, and in this case, this project is basically 2.6 miles, which is really pretty small. It's going to be at the low end of the typical type of scanning jobs. You could almost do this with a static scanner, but one of the things that made it suitable for us for testing the mobile LiDAR was the fact that you have several lanes in here. And if you remember that project that Paul brought up, when you start getting multi-lanes and divided highways, it really becomes much more cost-effective to drive it than it does to do it just about any other way. The other nice thing about this project that we looked for is it had some areas in urban, plus it had some areas in the rural aspect, so we could sort of see how things play. There, of course, in the urban areas, if you get into around buildings, you're going to have certain GPS issues. We wanted to see what those were, but we also wanted to see how it did in the rural areas. So one of the keys here that we did with some of our early projects that we wanted to work with this on was to pick projects that would test the technology, but at the same token, we didn't want to hold up a production or do anything that was going to interfere with production. So we picked projects that didn't have a real short fuse. The guidelines, and I'll see if I can bring them up, we established those last year, and I'll see if I can bring this one over in full. This one looks like it. One of the things that we established and was first off is I didn't want to reinvent the wheel. There had been a lot of good testing done by Paul's group. There was great testing being done by Caltrans, and several other DOTs were already putting mobile LiDAR through the paces. So what I really wanted to do was take the best of what they had done and add some things that we felt were important to us as a department and get something started, knowing that no sooner did we ink it on paper than things would probably begin to change. And so our document basically goes through the same things that you're used to probably seeing on other similar documents. We were very similar to Caltrans, but we came up with a Type C lower accuracy mapping component where they only had they had less than that. We wanted to make it available to doing asset management as opposed to just doing, say, a design survey for a particular, construction project. We also wanted to incorporate some of the other uses that probably will come about through the department. And basically what we ended up with is a document that was very similar. This is the one table here for very similar to what you'd see in Caltrans. And you have a Type A, which is a certain accuracy requirement, Type B, and then, of course, Type C. Go back one. And basically the big difference is the amount of control and the spacing. And I'll be the first one to tell you that one of the important things about the guidelines for us was to establish regular review process, albeit it's not as involved as a typical state procedure, but we needed a review process because consultants are basing their estimates on the guidelines for doing projects. So we didn't want to change the guidelines and then have that put them in the position where, which guidelines were they going for when they did the contract. So we dated the guidelines, and we have a set review process. We're coming up on a 6-month review in a month or two, and at which point we will review, the task team will look at some of the changes. And I can tell you now one of the things that we're going to look at is that the intervals for the validation points We think we can come off of some of those requirements a little bit, and I'd like to put in more cross-section requirements and maybe less of the NSSDA type of comparison. Also, too, we weren't sure when the Transportation Research Board was going to come out with their requirements, and but we needed to get something out there because people were starting to use this technology. So we had to come out with ours a little bit ahead of the TRB, but now that the TRB has come out with their set, we are also going to review ours in conjunction with that and, you know, see where we can have some consistency there. I like some of the thought process of getting away from, say, NSSDA point cloud evaluation to a more surface-oriented type of evaluation. And so the main point here is the guidelines are strictly that. We put them out there. We encourage the consultants to use them. We work with them. We're flexible on them. The key is to successfully use the technology to benefit the department and the citizens of Florida. So basically that's been the focus, and that's why we went with a less stringent, hard and fast rule setting component. Then we come to the staff hour form, and like I had mentioned before, we have a very involved estimating component that goes into almost any project that is done for the department. Pre-qualified consultants that do work for the Department of Transportation in Florida have, with very few exceptions, will do it based upon a set spreadsheet format for estimating staff hours. And so we needed to come up with an updated tab, which this is a tab for mobile LiDAR. We have tabs for location surveying. We have tabs for right-of-way mapping. We have a photogrammetry tab, as I mentioned. So this was just going to be another tab in a list of tabs that people could use to estimate staff hours. Now, the key component here is, in Florida, as in other places, we follow the Competitive Negotiations Act, the CCNA. So therefore, the staff hour form is strictly to estimate the amount of hours to perform a particular task, the amount of effort, and also too to establish a workflow. And as you can see, and I'll bring up let me see if I can bring up a better, maybe a little easier form to look at. This is basically a staff hour form, and the scan miles, would be the actual miles the vehicle drove. So if you've got a 2-lane road for 10-mile corridor, then you're going to have 20 scan miles. Basically, we came up with this and worked with consultants on it, and again, this is about the same category as the guidelines. It's in a very early stage. However, what this allows us to do, and I'll go back just a minute, this allows us to consistently look at the same sheet of music. We're looking at the same set of workflow components. You have the terrestrial mission planning, you have the project control point coordination, you have terrestrial mobile LiDAR mobilization, terrestrial mobile LiDAR mission, and terrestrial mobile LiDAR processing, and basically it goes through the workflow. And we came up with ranges that worked for most categories. And like anything else, what we're battling here is we want a staff hour range that is reflective of the efforts needed, but it also needs to be flexible enough to handle unusual projects. So we're always battling with, if we make the ranges too large, then they really are of no value, and if we make them too tight, they won't really apply to the projects that we want them to. So basically, we've started with a broader scope, and we're narrowing it down just a little bit as we hone in on our guidelines, because again, guidelines also dictate the same thing. So for example, if we change the guidelines on the amount of spacing for control, then the number of control points per project would go up considerably. Some of the other things that we have in this particular case, and I'll just do a couple of highlights. The transformation adjustment. You go from, most of this is field work, and then you get into the classification and editing and the office components. So at this transition, one thing that we have put here that I think is very important is if a consultant is a sub-consultant doing the actual mobile LiDAR work, they need to perform a survey report of the accuracy of that final LiDAR as it comes out of that adjustment, because everything else that comes after this point here is basically working off of that data. So the accuracy and all the measurements of accuracy are going to be done right here at the transformation and adjustment component. So if the prime consultant is doing that along with the rest of the mapping, then of course they just address what they did in their survey report of the overall mapping. However, if the prime consultant is just doing the actual attribute collection and a sub-consultant is doing the actual collection, then the sub-consultant has to have a surveyor of record to certify the accuracy of that point cloud. Because if and when things may not match up, we didn't want to get into a kind of a he said, she said, or finger pointing thing. We have a clear set of responsibility for what the final point cloud information was created and who created it. But basically this spreadsheet allows us to estimate the number of staff hours it's going to take, and the way we use it is the project managers and the people that are working with this, quite often now that they're new to it, will call me and I'll help them estimate a project, and we'll put it into this standard workflow. They will then take that and negotiate after they go through the selection process and all the number one has been chosen to do the project. They'll negotiate the hours on what they think it's going to take versus what the consultant thinks, and hopefully and in most cases they come to terms. This staff hour form as it is not used as a contracting form, in the sense that if I look back at what I had on here, it is not used as, it doesn't dictate lump sum, or it doesn't dictate limiting amount. This is strictly a way for the project managers to consistently come up with some realistic effort and the amount of time it's going to take to do a particular project. And it is a negotiating tool for the department. However, most consultants, although they fill out this form and they put their final values on this form, most of them, and myself included when I was in the private sector, we knew what it took to do the job, and we basically estimated the job the way we always did, and then we just put in the numbers where they needed to go to meet the DOT requirement. And that's pretty much what consultants will do with this form, is they're not required to use this to create their numbers. We just ask them to, when they do their final submittal of their actual cost, that they put it in this format so that we can match it up, apples to apples, and that sort of thing. Quickly, after the staff hours are generated, the form was generated, we also needed to come up with some generic scope, because we have a general scope item for all projects, and then certain things are put in for particular criteria. So we needed a set of general contract scope items that could be used in basically different contracts with consultants. And those all three go together. So really quickly, I talked to you about, and I'll wrap this thing up. Once we've done this, we still have, technology is still changing. New technologies coming on board. We have rollover in staff. All kinds of things change. So this process is really a continuous process. Even once we get them to really great, specific guidelines and standards and the things that we really do, something's going to always come along that's going to change that a little bit. So like I said, we go with our regular documents, we go with specific dates so that if a consultant was signed a contract on a certain date, they can match it up to the specific guidelines that were in place at that time. We want to maintain consistency of the documents, all three together and throughout the department. We definitely want to stay current with the technology. And this is a short-term goal that I put in there, is to reconcile some of the TRB guidelines. And that's probably what, like I said, is probably what we're going to do at the next meeting. But one of the things that I want to say, probably the biggest challenge of everything, and I'm sure I'm preaching to the choir to other individuals, whether you're with the DOT or with your private sector, the biggest challenge we have is maintaining the expertise of our staff. Technologies are changing, budgets are tightening, people aren't staying in the same positions as long as they used to. All these things makes it very difficult to maintain that expertise. And even now, we had here in the Florida DOT, we know that we're not going to buy a van or a vehicle and run around scanning and become scanning experts. But we still need to be experts to help quality control what we're getting. So we're having to think outside the box and team with consultants on projects. Our guys up here go and participate in projects. We have discussions at the early stages. Therefore, when a district who has a lot of responsibility to maintain project schedule and make sure that projects that the contracts are being met, they don't have the time sometimes to do the things necessary to maintain that expertise. So that's where our central office comes in. That's where I come in and the rest of the surveying mapping office and the Tallahassee office come in. We make it our business to stay on top of those technologies and maintain the expertise of our staff so that we can support them in their times of need and help them when they pick up the phone and they say, hey, I've got a special project, I want to use this, can we use it, and how do we go about doing it? And so therefore, that's probably the biggest challenge of any organization right now, is maintaining expertise. And with that, I think I can turn it back over to you, Rob.
All right, very good. We have a couple of questions. I think the first one here is for Brett. John Jacobs had asked if you have a guideline for when you use mobile LiDAR versus more traditional survey methods. Brett, I think that one's for you.
Okay. That's a real good question. I can tell you this: there is no set formula. And I'm sure Paul can tell you this as well. It really depends on a lot of different factors, safety being the primary one. I mean, we'll spend a little bit more and mobile scan a small job that we could probably do another way if it means keeping somebody out of harm's way. So I would have to say safety comes first. But then as far as being cost effective, that's one of the beauties of developing that staff hour form, because we had a couple of projects where districts wanted to get involved in this technology, but the only projects they had were fairly small. Well, we found since we started trying to plug the numbers into that staff hour form, the ranges were shot all to heck, and that was because we were trying to put too small of a job into that criteria, because really the jobs we were thinking about using them on could be better done with static or a different means. So there's no set number. I think safety comes first, and then of course it's basically how long is the corridor going to be, you know, and that probably dictates it the most. But there is, I'm sorry to say, there is no set formula. At least I haven't found one.
Brett, you mentioned safety. What about issues like congestion, operational integrity, you know, those types of issues where the mobile allows you to keep lanes pretty much open to traffic? Do you look at traffic volumes and some of those issues as well, or is it just primarily safety for those who would be doing the surveying?
Well, most of the scanners can travel at speed. Even on a high speed, they can go the minimum, which in Florida I think is 45 or 40 miles an hour on the interstate. They can at least achieve that and get most densities that are needed. Most of the time, the nighttime scanning is done primarily to reduce the amount of ghosting images or the amount of objects, moving objects that are caught inside the scan, like other traffic. It works well if you're not looking for regular imagery to go along with your scan. Like if you're going to use regular imagery to go along with the scan so that you can help register what's a curb and what isn't, and you know, it's a very popular method. You're either going to have lighting or you're going to have to do the imagery during daylight hours. So, but to answer your question, most of it's done for collecting the data without interruption from vehicle traffic.
All right. We have a couple other questions related to the documents you talked about. A number of individuals are interested in whether the guideline document can be downloaded, and the Excel spreadsheets that you used, are those available anywhere?
Well, the guideline is published and it's on our internet site. I will make those files available to you for the immediate dispersal, and once we get moved over to our new digs, they will be able to get on our website and be able to download most of these documents. The staff hour spreadsheet hasn't been adopted yet. We have a formal adoption date coming up probably early next year, where they're going to be incorporating these and several other changes that were made to our overall spreadsheet. However, I don't see a problem with giving you guys the draft that we have. Just check back at some point to see what our final version comes out to be.
Great. So any who are listening to this, if you're interested in these documents, you can email me. Brett, do you mind if they email you directly? Your email address is here.
Oh, not at all.
All right with you? All right.
Yes.
Since the email addresses are here, if you're interested in those documents, just email Brett, and he'll get them to you as soon as they're either available or in regard to the spreadsheet and the other document, I would imagine right away. We had a question about, and I guess this one is for Paul. You mentioned earlier about the half-inch 1 sigma absolute accuracy, and the question is the half-inch 1 sigma absolute accuracy good for all types of surfaces or only for hard surfaces?
That's a good question. Primarily, we're looking at the hard surfaces, the pavement and the surrounding structures, retaining walls, things of that nature. The problem is when you get into areas that are grass, medians, and infields, like the interchange I showed you, you can have some trouble establishing exactly where that is. The beauty of most of these sensors is that they do have the ability to establish a final return on as they pulse the light. We can distinguish vegetation from ground, so we can sort that out. But there is, I would say, you know, the consistency of that result is probably questionable. So the direct answers would be yes. We're focusing on hard surfaces there with those RMSC numbers, and I would say that the other surfaces are not far from that, but it's an inconsistent type of result.
All right, fair enough. We had a question as it relates to I guess the question is, what would you say are the top technical issues faced by both HNTB and Florida DOT?
I could start with that. I would say that our biggest challenge from a technical standpoint is the education for all of our project managers and our clients alike, so that they understand the potential for the technology. That's just it's an ongoing battle. I think we're creatures of habit, and we would prefer to do something that we know will work versus venturing out into the unknown and trying something that you're not sure about. So we've, over the last 4 years, have really had a lot of, we've taken our lumps. We've had projects that have not gone well. We've had projects that have gone exceptionally well, and those lessons learned, that the list of lessons learned grows. So, I think that we're turning the corner now. If you look at the S-curve of technology adoption, we're just past the knee now, and we're kind of getting into that mainstream where it's starting to gather some momentum. But as Brett said, it's ever changing. The technology's constantly being updated. We're getting faster sensors, better navigation. We're learning better ways to geometrically change the data, through corrections. So there's a constant battle to stay ahead of that and understand what these new technologies can do to improve our process. So they're the two things I would say: the education, and then that constant change in the technology.
This is Brett, and I would concur 100% with Paul. As a surveyor and mapper, quite often we're asked, what do we need to do for this project? And I always put it back, really, it's how much risk mitigation do we want to do? How much risk mitigation does the designing engineer or the department want to have? We very rarely dictate how much effort is done. It's mainly what the product is. And I think from that standpoint, what's really starting to accelerate that knowledge base that Paul's talking about is the move to going 3D design. For the most part, photogrammetry and surveying and mapping, we work in 3D, and then we create, information, and it gets put into a 2D map, and then it has to be brought back out when they start wanting to use the surfaces for automated machine guidance. So I think what's really accelerating this, I think, is the fact that there's a move and there's a definite benefit to going to a full 3D design, as when you look at the cost of the project from beginning to end, and not just in a particular phase like the design phase or something like that. So now that we're looking at projects more from start to finish, I think the little bit of extra cost, because there's not necessarily a big cost savings to jumping to mobile LiDAR versus doing it conventionally. All you're really doing is getting a lot more information for your money, and you're probably mitigating a lot more risk than what was being done before. So I think the 3D design part has been a challenge, and I think that's really taking off. And the other part is, like with all technologies, it seems like part of it jumps ahead, and then it takes a while for the rest to catch up. We can collect so much data now in a short period of time, but now we're trying to figure out, okay, how do we store it? What do we do with this data now that we have it? Because this LiDAR data is similar to an image in the fact that it has intrinsic value beyond just the original intent of the project, and even historically, because we quite often bring up historical images for our IG's office in court cases and things like that. So there's also value to this imagery. So how do we store it? And also too, the main software component people are coming online, but for a long time there was no way to really, you could collect all the data in the world, but trying to manipulate it with the technology we had, 32-bit before 64-bit and all that, was very, very cumbersome. But now that it's becoming more and more streamlined, and with the 3D design, and once engineers can bring up a little patch of that point cloud and have confidence in it and see where they want to make the measurement to, rather than just take the word of somebody else, I think that's really that's when the thing is really going to take off. And I think we're moving in that direction with the 3D design really quickly.
All right, we're down to the last couple of questions. One of them is, Brett, they're wondering how you select consultants to help you with the mobile scanning. So are you using RFQs, and how do you build your proposals, et cetera? How do you qualify people?
That's a good question. We have a pre-qualification process in the for anyone doing work for the Florida. But really the pre-qualification process is not so rigid. It's really sort of, it keeps you from getting hundreds of thousands of responses to a project. It really doesn't, go into a great deal and really determine whether someone's qualified. That's handled under, our professional surveying and mapping component. But you do bring up a very good component, and I guess from an agency standpoint, we're able to stay out of trouble because we have the people with some knowledge in the area to keep us from making major mistakes. When we do this consulting, got the team on for the task team together, we took consultants that were already pre-qualified to do photogrammetry. They were already correcting SBET or smooth best estimate trajectory type of things, meaning they were already correcting for sensors in motion. And we also have consultants that had been working outside of the state that wanted to come and demonstrate what they could do, and we had them come and demonstrate some of the things that we were doing. But in essence, we really didn't make it restrictive, and it's kind of interesting because coming from the private sector myself, it's really been refreshing because people hold each other accountable. No one wants someone to get in here and mess up a project, and it's going to hurt their ability that they've invested a lot of money in. So, there's really a lot, you don't have a lot of people that really don't know anything trying to take the lead in these situations, and you really have the other components holding them accountable. So basically, we created a group from representatives from each district, and then they made recommendations from consultants that were doing similar type of work. And then, of course, we didn't exclude anybody. If somebody really felt like they wanted to be a part of it, we let them in. But we didn't just throw it out to everyone, because once a group becomes too big, we can't actually make any decisions. So we wanted to keep it small enough to be flexible. But we really didn't exclude anyone. Basically, everyone held each other kind of accountable. No one wants to go out there and get in trouble.
All right. We're, again, down to our last couple. Do you use LiDAR for post-construction purposes, such as built plans?
We are not yet, but that is a hot item, and I know that's been a discussion I've had with the state surveyor, and he's had it with other people. It is coming. I don't see any other way around it. I think it's too valuable.
Okay. Do you typically, are the point clouds typically delivered to the designers and even the contractors? And if not, why not?
Okay. In a nutshell, we haven't worked all that out yet.
Okay.
The simple answer is there's a lot of LiDAR out there. We had coastal stuff done, and what's happened is you go to water management agencies and other agencies, and they all have the same LiDAR data on their system because they wanted to get a piece of it too so that they could use it. But the amount, the size of these files is even larger than that of a lot of imagery. So to store this on multiple machines is really not very cost effective. So the real reason for not delivering all of the cloud to everyone is because it takes up a lot of space, and not everyone really needs to get down to that level. And in fact, some people that want to use it, you don't want them to get down to that level, because it's sort of like giving a contractor a bunch of survey field notes and saying, okay, we staked it out, here's the field notes, go build it just on the field notes. It's kind of like that's the raw information. You don't know if the ghosting's been removed. There's not, every point cloud is not created equal. So the bottom line is we're looking at cloud-based support. There's a lot of things out there that are doing similar to serving up imagery, creating a LiDAR server in the sense that you could bring up a feature like a road, and then it would load the points that were used to establish that road, just the points from the point cloud for that road, rather than the whole kit and caboodle, which would save a lot of time. So I think whatever we come up with is going to, in some way, create a centralized storage for the cloud data, and users can access it as they need it depending on what their needs are. However, you've got to be careful with that in the sense that it might have been done for asset management and then somebody grabs that point cloud and tries to use it to design a road. So we've got to, you know, there has to be levels and priorities put in there, or we end up with a lot of confusion.
Well, let me just ask one last thing then. GTMA is working, or has been working on developing an asset guide to go along with AASHTO's Transportation Asset Management Guide. And my question to you and to Paul would be, do you think there would be value in having GTMA work with AASHTO on developing something similar to the NITPEP process, the product evaluation program, where test decks similar to ones that have been set up in Alabama, in Utah, to set up a standardized pre-qualification, possibly even working with universities like TTI and others, Virginia Tech, to establish a process where contractors could become either pre-qualified or at least be able to demonstrate in a manner that would be acceptable, at least have widespread acceptance for everything from asset collection to what we're talking about today, which is more along the construction and survey side. So from both of you, Paul and for Brett, what would you think? Is that something that should happen, or would it be of value?
Rob, for me, I think it'd be very valuable to have, you know, anything like that where the standards are understood by everyone involved is going to be valuable. And, you know, just like Brett was talking about syncing up with TRB earlier, you know, it's going to have to come to that at some point where we are all working off the same page of music, and we understand the different types of collects and the different accuracies that can be achieved. If we can get something like that established and distributed, I think the industry will benefit from it.
Yes,
Brett,
Rob,
is there value for Florida? I'm sorry. Go ahead, Brett.
Yes, and that's definitely something that would be of value in our qualifications process. We certainly have that. Would like to have that with mobile LiDAR and other things. And I think from an agency standpoint, I think it would be tremendous, because we sometimes it depends on whose ear the person that has the idea talks to, and quite often they'll get started on something that really can't quite meet what their requirements are. And if they happen to come talk to the survey department or some part of the design office that is knowledgeable in those things, we can set them straight. But sometimes that doesn't happen. So having some sort of process like that would certainly give the department as a whole a lot more confidence in what's being brought to them.
All right. Well, wonderful. Well, first of all, let me just thank each of you for your presentations today and for the questions. Everyone, please, again, take a look at the screen. You've got the email addresses for both Paul and Brett. And I would encourage you, we didn't get to all the questions, so please feel free to contact them and to with any additional questions you may have. But we've certainly benefited from this, and I will be taking back some of the comments and suggestions, even some of the questions, back to GTMA's board at our upcoming meeting, and we'll go from there. But again, Paul, Brett, thank you both very much, and everyone, have a great afternoon.